Okay, so I think we'll go ahead and get started. I think a few more people will probably be trickling in, but first, thanks for joining today. So really, what we wanted to be discussing was challenges and best practices around test automation in a regulated environment. And from a best practice standpoint, we want to be talking about that from a process standpoint, establishing a test automation framework successfully, and then also get into a bit on the technology side of things, right? So what tools can enable effective automation, and then more importantly, what tools can kind of support that in a regulated environment so we're not limiting the efficacy of test automation tools. So presenting today, we have Nadia Znachko and Henry Farris. If both of you wouldn't mind giving yourselves a quick introduction to the audience.
Sure. Thank you, Jason. My name is Nadia Znachko. I'm Global Head of Quality Assurance Automation Chapter in Luxoft. Happy to be here presenting to you.
Yeah, and hello, my name is Henry Farris. I'm the product owner of Vera, the Tricentis Vera product here at Tricentis. My background is in computer systems validation and test automation.
Okay. So like I said, I kind of talked about this a little bit, but we want to start off from an agenda standpoint, talking about some of the challenges of test automation and regulatory compliance, getting into establishing a test automation framework, and then get into a little bit about the regulatory challenge and computer systems validation and start addressing some of those things specific to CSV. And then we'll spend some time covering the tools that we're talking about from a solution standpoint that life sciences organizations or other regulated organizations can leverage to adopt effective test automation for regulated application testing. And then, as we had mentioned in the invite, we do want to have an open forum discussion of this presentation. So at the end, we wanted to make sure that we had some time for the folks in attendance to do some peer-to-peer interaction, as well as engage with HB and Nadia from the subject matter expertise standpoint, and really just kind of answer any questions or topics that you might have that you want to discuss around regulated test automation. So as we go through the presentation, if you do have any comments or anything that pop up, feel free to enter them into the chat, and then we'll get to them as we get into the open forum discussion. Or just kind of keep them in the back of your mind and we can make sure that we address them there. So with that said, I'm going to go ahead and pass it over to Nadia now to start the presentation for everybody.
Thank you, Jason. So I'm here to talk today about the specifics of testing for validated systems and compliance validation, and how Luxoft and Tricentis have joined forces to address the main challenges of it. Luxoft DXC technology is a part of DXC family and has been providing high-quality software engineering services to our clients in 3 geographies for more than 20 years. We have been working with hundreds of clients on a range of engagements, including running and executing large digital transformation programs and covering pretty much all of the technologies and services in change the business space. The range of industries that we have been engaged in cover financial services, healthcare, banking, life sciences, automotive, retail, telecom, and others. Our forte since the inception of the company was to find the right talent that ensures combination of engineering finesse and specific industry knowledge. We have always believed that to build the right system, we need to have people who understand the business needs and underlying problems and have subject matter expertise in a particular space. Luxoft and Tricentis have partnered for over 2 years already. We're combining our integration technical expertise, knowledge in specific industry domains, with a cutting-edge solution stack from Tricentis side to address the quality objectives of our clients together. This partnership allows us to provide better services to our clients in quality assurance space. We're acting as an enabler for large transformation programs for a variety of industries. And in addition to the right combination of the elements that are critical for the delivery, we also work on a range of in-house build accelerators, creating redeployable IPs assets that would benefit our clients in future. Next slide, please. Just a very short overview of the credibility points. Luxoft brings on massive expertise and proven track record of delivering integration projects in different industries. It suits well with Tricentis lead market solutions in variety of quality assurance areas and unlocks significant cost reduction and time to market improvements. In Luxoft also, we have developed a range of training programs which cover both engineering skill improvement. We are getting our people up to speed with a new tech stack or with the new tools, as well as domain expertise improvements. For example, if the training is needed on the new regulations or specifics of a particular regulations of how it's being applied in a different type of geography. And another field where there's also a lot of benefits from the partnerships that we have is dedicated testing for vendor platforms and their integration into the existing ecosystems to cover the end-to-end flows with the highest priority and level of business risk coverage. Using Tricentis tech suitable for both platform testing, so isolated platform testing, and for enterprise end-to-end testing to address the integration points and system integration points. Next slide, please. So results of this partnership, we have a number of services that we provide jointly with Tricentis. They're all illustrated on this slide, and specific focus of today's session would be on regulatory testing. And I suggest we just dive right into it and switch to the next slide. All right, so testing for validated systems. Testing for any kind of compliance or regulation can be really painful for the team that is assigned to do it from a variety of aspects and reasons, starting with an increased looming sense of responsibility that lies with the quality assurance team and ending with a strict deadline that has to be followed for regulation testing. As we know, testing, being the last stage of the process, can often be delayed and thus perceived as a bottleneck for the whole development. And a big bucket of challenges that is related to this type of delays lies at the very beginning of the process during requirement specification and analysis that needs to be done for the requirements. It does not make it easier that usually validated systems do not have testable requirements, which means that on the off chance that requirements are actually available, defined on time, and are with the testing team, they still may not be easily transformed into test scenarios or are unable to be linked to the actual regulation for reporting and audit that comes later. This leads to increased amount of analysis and designs that needs to be done by the testing team. And it's a major overhead. And here where another challenge can kick in, if the team assigned to do this work has gaps in knowledge for this subject of validation, they may struggle to get clarifications in time, thus being further delayed in the process of the test design specification. This leads to this major overhead, and it could be worsened even more if there is no good defined process of review and acceptance done from the side of business analysis team or the subject matter experts assigned to and responsible for the regulation delivery. All of that leads to a lot of delays at the early stage of the project, and in the best case, this is in the best case scenario. In the worst case scenario, important requirements are misinterpreted or fully missed from the coverage, and it leads to fines, approval, delays for the approval, and other potentially legal consequences for the implementation piece. When all of the items around the analysis, design, and traceability are finally resolved, when they are resolved, there is another type of issues that come into play, which are technical difficulties in automated the required testing. As we all know, automation is the future, and only a limited amount of things should be covered in manual approach. So it is important to be able to implement the automation effectively. And here, one of the tricky aspects is tool selection and its further usage. Picking the wrong tool is, like, for example, the ones that cannot be fully integrated with a test management or configuration tool, or the ones that leads to major maintenance issues while being integrated. It adds complexity for the reporting, reusability of created test scripts, or audit. And sometimes it also leads to taking the manual approach for the items that otherwise could be easily automated but cannot be done because of this type of non-suitable tool. And in addition to the tooling problem, there are a lot of complications that are related to test data. So it's connected to the tool because test data is something that you feed into the tool, but also you need to make sure that you are creating, updating, and maintaining the compliant test data. The lack of data sources or effective integration of the data sources and ability sometimes to mock or create the virtualized services to mock the data points. It can also like slow down the process and lead to not being able showing relevant coverage for the data specific types of testing. And the last item to be highlighted on the challenges side is the amount of legacy approach and processes that exist in the field. Validated systems testing is majorly manual right now. There are a lot of legacy practices, and professionals involved in the development are often following those type of approach, like legacy waterfall approach, where it just becomes suboptimal in terms of the deadline because all of the testing is bulked up at the end of the process, and there are often things missed that I have already talked about. To address all of these challenges, there are several of the best practices that can allow to mitigate the impact, and I'll just going to quickly summarize them. So the first and foremost, assigning the core team members with full understanding and expertise in the regulations and audit requirements to do the analysis. This would help to identify and eliminate requirement gaps at the very beginning, ask relevant questions, create a traceability of requirements to tests that could be reused for further reporting and test automation results capturing. Making sure that it also fills into the tool set. So if we know all of the requirements and all of the existing gaps, we are able to have more educated choice in terms of the tools assignment. Then organizing and conducting sufficient amount of review sessions is important, and is to cover the sign-off both for the test designs, accept the level of test coverage, accept priorities of execution, make sure that everyone is in agreement for the testing plan, and also the test results sign-off at the end, which means acceptance of the level of evidence captured, the SLAs that have been tracked, the metrics that have been displayed in the reports, and so on. So this type of review sessions need to be planned for and executed in the efficient manner. Approach to test automation and test automation strategy is also a big way to resolve most of the challenges. It should be clearly defined, and it should address the following: making sure that selected integrated tool has an ability to capture the evidence and results of testing, and that it would be done in coherent and easy interpret and easy to access manner. Also, that there is a possibility to have version control synchronization for the test scripts update, which would in turn simplify the maintenance for the test scenarios, and prioritizing test execution for organized suites in a way that will decrease the time lag between defect detection and reporting. Especially this is important when there is different level of risk for different functionalities. Reorganizing test suites in a way that the most important tests are executed first makes sure that the most critical defects are reported at the very first place, and you can start fixing them as soon as they appear on the test report. So if we could switch to the next slide, or maybe if there are any questions right now, we can cover some. I don't see anything in the chat so far. And if there is nothing, we can just switch to the next point. Okay. Here, several elements that need to be in place for implementing successful test automation, not just for validated systems, but overall to ensure the success of this type of implementation. The first very important point is taking on an agile approach rather than waterfall. When testing validated system, time is of the essence due to the deadlines, as we mentioned already. And taking waterfall approach in this case would mean starting automating when development is done. And this is simply like, so it does not allow to enough time to complete efficiently the testing and meet the deadline of the release. Here we need to take on agile and parallel testing methods to ensure the in-sprint automation, fast feedback loop, and ongoing collaboration with the dev team. High quality test design. I have mentioned a couple of times already how important it is to write the right tests and to have the right level of traceability for the coverage itself. There are a lot of things dependent on knowing what needs to be tested and how to do it in the most efficient way. And the goal here is to minimize the number of tests and maximize the coverage at the same time, and to keep the traceability, especially if we are talking about regulatory testing. Every test that is being executed and the test results need to be able to trace back to the specific regulation, especially in the times of audit. You need to be able to show it right away. Automation tools and DevOps integration. We need to select the tools based on their compatibility with each other, with environment, and with technology that is needed. It requires to have a sufficient amount of analysis done upfront to be able to make the choice about the tool set. Sometimes the right choice is to build a specific framework. Sometimes it's better to buy commercial solutions that is the right fit and has the right level of support and will not bring an into the testing team lives to maintain the framework in addition to maintaining tests. HB actually will cover a lot about the tooling in a couple of minutes when I'm done with my part. And of course, one of the big parts of automation success is DevOps implementation. The only way to unlock and maximize the value of test automation is making it a part of CI/CD process and making test automation execution as a part of the pipeline. So this is the way to continuous testing and eliminating the time lag between reporting and fixing of the issue. And having the right DevOps practices is very important for the success of test automation overall. And last but not least, that deserves mentioning is keeping an eye on infrastructure and test environments. There are often a lot of issues which are connected with infrastructure and test environments availability or stability. And this is something that needs to be a part of test strategy. Next slide, please. Okay, so how do we make sure that a person who is assigned to work on the project is capable of addressing all of the challenges that we have covered? We will refer here to the so-called SME talent triangle. And there are three sides of competencies that we look for and nurture in the people whom we hire and assign to the projects for validated systems. It's technological skills, domain knowledge, and risk and change management skills. Industry and regulation knowledge is crucial, and it needs to be combined with analytical skills for the testing team, which would help to work on a comprehensive test design specification, covering all the right requirements in sufficient manner, both requirements in isolation and holistic end-to-end view of the system. Because whenever we are testing any new regulation, we need also to make sure that none of the old requirements are broken or contradictory to the new set of requirements. And this type of knowledge is built through knowing the systems themselves, the ecosystem and infrastructure, as well as the business aspect of the items to be tested. Technological skills, essential for test automation, essential for execution, for maintenance, and basically to doing day-to-day activities within the selected technology. And the last part of the triangle is risk test management and change management. This grants that the prioritization of testing and volatility of situation on the project is competently monitored and reported to the relevant stakeholders, and that we can handle work on the project in the most efficient way and have the clear communication and also mitigation plan for the risks that can exist and occur in the testing environment. Especially knowing how fast the priorities can change, working in an agile manner implies that the professional should have a certain amount of knowledge on how to manage change and how to manage risks. Next slide, please. Just to finalize on my part, before I hand over to HB, I would like to spend like 2 minutes speaking about the 3 greatest challenges of making automation work in the long run. Because what is the main target for us is to implement test automation in a way that would last for years and bring return of the investment as the things progress and new requirements need to be covered by testing execution. So the 3 big parts are test environments, test maintenance, and test data. I have mentioned all of them to a certain amount already while talking about the challenges for validated systems. All these 3 elements need to be sufficiently covered as a part of overall test automation strategy. For test environments aspect, we need to address the ownership of test environment, the health checks that needs to be done, the ways to ensure the stability of environments and its availability at the pointed time when the test needs to be executed, and also supporting the DevOps implementation piece. It needs to be defined who owns the environment and in a very clear manner what is the escalation part if for some reason environments or components of the environment would be unavailable. As well as that, we need to account for the need to create virtualized services or mocking the certain data points if we know for sure that they're not going to be available at the time of testing. For the execution piece, we need to be prepared to cover that. Test maintenance deals with the growing amount of tests, and it becomes crucial in the long run when your test packs are raising in size and you need to do this housekeeping to avoid the test bloat, because the scope of testing grows. So does the effort required to maintain it. It can bring on the issues with having too many false positives and false negatives, and making test results unreliable and making your tests non-reusable. And basically you are having this large test sets, half of which are never executed because you can no longer trust the results and you don't have time to fix them. So you need to have a certain approach and certain level of simplification from the perspective of technology to be able to manage the times that is needed for the test maintenance. And the last piece is about test data. Test data approach definition that should cover both ways to get the prod-like data and to synthesize the data that would cover predictive scenarios of the data sets that do not exist in prod right now, but could potentially be an issue in future. So with that, I'm done with my part. Maybe there are any questions before I hand over to HB to jump into the toolset. HB, over to you.
Okay, thanks, Nadia. Appreciate it. So again, that was a great session there on test automation, how it fits into validation, and some of those challenges. Thank you very much. So how do we actually meet those challenges? How do we address them? Well, Tricentis has a digital validation platform for regulated environments like life sciences companies. The reason being is most of the tools that we like to use from a development standpoint, test standpoint, requirements management standpoint, don't meet these life science customers' electronic record and electronic signature requirements. But that's okay. Our digital validation platform, Vera, brings in that 21 CFR Part 11 or Annex 11 compliance so that you can use these best of breed tools and not worry about those requirements, because Vera will bring all those additional requirements with our integration to those tools. Now that includes the electronic record and electronic signatures themselves. It also has the ability to segment the segmentation of duties capabilities for review and approvals, the chain of custody, so that we can ensure that the actual life cycle of these particular records are enforced, and of course audit history is in place. Now, this digital validation platform, Vera, does support computer systems validation and computer software assurance practices as well. And that could be a traditional waterfall practices that we talked about, but we can also support agile processes. So we can actually take all these validation activities and start shifting them left, as we always say, right? We all say shift left, be it lean or using SAFe or DevSecOps or some other agile process, being able to actually move from this very large independent validation process and trying to incorporate that more into an agile environment. And a big part of that is shifting from the legacy concept of approving documents and PDFs and storing those in document management systems and moving those into a digital validation platform where we're approving individual records. And that could be the user stories instead of big requirement specifications. That could be your individual manual and automated tests instead of test protocols. And that could be your execution tests and test results of those manual and automated tests, and being able to prove those individually and having a much lighter weight review and post-execution approval process and test summary report approval. And then in addition to that, any defects, issues, any deviations, any findings that are detected can also be added and incorporated into this digital validation platform so that that item can be reviewed, a disposition or mitigation can be put in place or fixed, and that item can be closed, reviewed, and approved as well. And basically how this all works as we're moving away from these documents to records is with this integration with Vera, we're ingesting records from these source systems, be them requirement specs, test cases, automated tests, test results, or defects. When those are ingested into Vera, Vera evaluates those records against the customer configured approval policy and basically matching up that record to the appropriate approvals that need to be performed on that record. And that's highly configurable, where you can pick the type of approvers, what those approval roles are. Is it is it ITQA? Is it validation lead? Is it technical? Is it system owner? Is it business process owner? All of that's configurable so that you can pick the appropriate approvers for any one of these entities or even sub-entities, and even enforce the order of those approvers and approvals as well. Thank you. Now, this is a Vera is a central platform. Again, so the idea is that it's a standalone application that integrates with these different systems. So we can integrate with agile management like Jira. We can integrate with requirements management systems and test management systems like qTest and other test management systems, so that we can ingest all these different items. As I spoke about on the previous slide, we can ingest all these different items and create these approval routes and then construct an approval queue for our users. So how this works is, for instance, in what you'll see in later slides is that when we route an item for approval, that item gets ingested into Vera. Email messages are sent out to the individual users that need to approve this, and there's an approval queue in Vera that a user can actually see all of their work that they need to perform from a review and approval process, be it requirements or user stories, tests for pre-execution approval, test results for post-execution approval, or defect remediation review and approval. Right. But now what we're concentrating today is really involved in test automation. And so I'm focusing on our integration with qTest and Tosca. So this is Vera, qTest, and Tosca. Now, granted, we do integrate with Jira. We also integrate with some other test management tools, but the focus today is going to be on these core products. And what we can do here is with qTest, we can use that as our test management platform, where we can do things like define all of our requirement traceability, define any manual tests that need to be created, actually get visibility into the automated testing that's being developed and executed, and even schedule those automated tests. And qTest also has some orchestration capabilities. They have a pulse tool where we could even build in processes as well, instead of just doing a hard-coded execution, but actually have process triggers for executions as well. And then with all of this, test orchestration, test management capability, there is a reporting engine as well, so that we can do things like view test summary reports and generate test summary reports out of the tool, generate traceability matrices out of the tool, so that from an audit response standpoint, we can leverage some of the reporting out of qTest to meet those audit inquiries. Now, on the other side of the slide, when we talk about Tosca, Tosca is an enterprise testing tool, right? It has the ability to do no-code automation, keyword-driven automation, and the use of reusable modules to actually create your tests themselves allows for the rapid creation of test cases and the lower maintenance costs of your test cases as well. And since this is an enterprise testing tool, we could support desktop applications, web applications, API testing, database testing, browser-based testing, and mobile as well. So with that capability, not only can we just create requirements-based functional tests to just basically ensure that requirements are being satisfied, we can also create very sophisticated end-to-end testing across different systems to automate very complex business processes, which can be very time-consuming, and in the past, for manual testing, provide a number of SMEs across different disciplines. And those SMEs may even be geographically separated as well, so that maybe there's a test that if I knew how to do all the steps of that test, I can execute it in an hour or so. But bringing those other complexities of different systems, different locations, trying to coordinate manual testing could take days. And now we can even reduce that further with automation and bring those days down to minutes. So with the and then in addition to that, sorry, I paused. I wasn't done, Jason. My apologies. Now, in addition to that, we have the AI capabilities with Vision AI to make the actual identification of our test objects easier. And Tosca also has capabilities like risk-based testing definition, where you can actually define your requirements and come up with a test bed based on risk as well. And then, as we mentioned previously on previous slides, we have Vera, where Vera is actually used to ingest records created in qTest and in Tosca, in these cases in test management for pre-execution approval and post-execution approval processes, where we'll ingest those records, identify the appropriate approvers for that record, and then notify those users when their approval is pending. Okay, thanks, Jason. So how does this all work? So again, this is an integration between three systems. And again, it's because we want to put all of the compliance areas inside of Vera, allow Tosca to be the best automation testing tool, and allow qTest to be a best-in-breed test management tool, right? And instead of plugging in approval capabilities in each tool, that would require a lot of additional training for your SMEs, because they'd have to learn these different tool sets, where what we're doing is we're pulling that in a central portal. All those different users with all those different roles that we saw on the previous slide only have to learn one system. They only have to learn Vera in order to provide their review and approval capabilities versus 4 or 5 different tools. So how this integration works today. Now, it all starts with a requirement, right? So we have, as Nadia was mentioning, we have these validation requirements that may not, that we need to ensure are testable and are written appropriately. So those are going to be defined, and they'll be visible in qTest. And that will be the start of our process, right? So from there, we're going to identify our test cases. And we could either define those test cases as manual tests in qTest, or they could be directly created in Tosca. And so you can define your test case and underlying modules in Tosca directly. Now, if we define them first in qTest, we can actually use a convert mechanism to create a straw man of that qTest manual test to create an automated Tosca test in Tosca, and it'll create all the linkages between qTest and Tosca to support that integration. Now, if I created it first in Tosca, I can then link that Tosca test back to a qTest test, so that in qTest, I have full visibility into all the manual and automated tests that are part of my testing suite in the test design of all of my testing. Okay, so we created our tests, and now my test engineer is working in Tosca and defining all of the underlying modules and configuring the test and testing it, making sure that it works properly. When we're done with that automation, we then want to have that test reviewed to ensure that it is actually meeting the requirement itself, that it is executed, that is verifying, that it actually proves that that requirement is working. So from there, once that test is complete, it'll start a review process. So in qTest, we'll ensure that that automated test is linked, that Tosca test is linked to a requirement, and then we'll route that requirement for approval. Now, at that point, once we route this item for approval, the actual test is going to be locked, both in qTest and in Tosca. It's not going to be modifiable while it's going through this independent review. And that independent review is going to take place in Vera, where they're going to look at the requirement, they're going to look at the automated test or tests, and look at the coverage and say, yes, this automated test is actually covering the requirement, and then I'll approve that item. And a number of people have to approve it for it to be fully approved. And then if it does not, I'll reject the actual approval request and provide information on why I'm rejecting it. Is the requirement coverage incomplete? Is the actual automated test not exercising the appropriate requirement? Are we not following our framework when it comes to automation? Maybe we're not following the right naming standards for our modules, or the organization of the test case itself is in the wrong location. Whatever that may be, we reject that item, we provide that rationale, and it goes back to the test engineer to now fix that item. So once we reject that item, we do have the ability to correct that item and then route it for a subsequent review. And we'll go through that process until that test is approved. Now, once that test is approved and the number of tests are approved, and we're constructing our test suite, that means that the test is now available for formal execution because we've gone through that pre-execution approval process of the actual test case. Now that test is available for execution. Now, this can be executed a number of ways. It could be manually triggered in qTest or Tosca. There could be a process trigger on a build process or a commit process that comes from a CI/CD tool or Pulse. And it could just be a scheduled trigger where it's actually scheduled in qTest launch, where we can actually just say, okay, we're gonna schedule this to be executed at X time. Now, once that execution takes place, all those results, those test results, are going to be stored in Tosca, and the general status will be stored in qTest, where we can actually see what tests passed or failed. But it's more of a dashboard level reporting in qTest. So I can actually see which of my tests passed, which of them failed, and then investigate all the test failures that occurred and go through that iteration until all of my tests have passed, or that the ones have failed, we have identified defects and a remediation, and either that defect is going to be fixed, or we'll determine if the defect is not something that will prevent release, and we move forward with a failed test result and an open defect. So we get to that state, and now at that point, we're like, okay, we have these past tests, we have these failed tests. During that whole execution process, as we shift left, instead of waiting until the very end and approving all those items at once, as we do our test executions, we can route those test executions for post-execution approval as we go. And so instead of having this gigantic review process all at once, I am incrementally getting my test results reviewed and approved or rejected with actions to take in order to get those items approved. We go through that entire process through post-execution approval. And once we have that done, we're actually at a point where we can say with a lot of confidence, okay, our testing is complete. We did our post-execution reviews and approvals, and those reviews and approvals are complete. We're now at a point for a good go, no-go decision from a validation standpoint to release this product. And that's really what we're trying to do. We're trying to leverage this test automation in order to claim it as part of your validation deliverables, your validation practice, your validation package, excuse me, and leverage all that automation capability to reduce the amount of manual testing spent on regression and focus that testing on either exploratory testing or ad hoc testing, for instance, and be able to reallocate your testing resources accordingly. Now, that is just one particular release of the software, right? We can even say that's the initial release of our software. We went through this process of building up our automation library, creating our tests, getting those tests pre-execution approved, and then executing them for that particular release. Now, at this point in time, I have a bunch of tests that are approved, which means they're under control. They can't be modified, and they can continue to be executed for any subsequent release with a high degree of assurance that that test case has not been modified at all because it is under control this whole time. Now, with that in place, we'll be able to continue to use this group of tests release by release. And then in the occurrence where we do have a change that occurs that impacts a requirement and then impacts one of the automated tests, we would go through a revision process where we'd actually take these tests that were pre-execution approved and trigger them for a revision process where we can say, okay, this test needs to change, this group of tests needs to change, which will then unlock those tests and allow for modifications. Now, Vera will always maintain the approved versions of all those previous tests that are now being superseded by these new versions of the tests, so that from an audit standpoint, we'll always have the approved test versions themselves, as well as any test results associated with them. Now, that's how we can support that traditional computer systems validation process. We can do it in a waterfall manner, or we can do it in a more agile approach. And as we see more adoption of CSA, we'll even be able to adjust what we approve and how we approve items to be more nimble with our test execution methodology. All right, thank you. So, and we do have some customers in action already using these approaches. So here's a customer that has a very large SAP implementation that they're able to successfully automate non-GXP modules in SAP, ones that didn't directly impact patient safety. And they already were reaping the benefits of the test automation. With this integration with Vera, they're able to extend that automation over to the GXP modules of SAP with this pre-execution approval and post-execution capability. So they're able to extend their automation across SAP and be able to claim that those test results as part of their validation efforts and their validation packages. So again, the nice thing is that they're able to again, the benefits of automation are universal. It's the matter of being able to leverage automation against these GXP applications. And so we had a big reduction. We had a ton of automation, a big reduction in execution time, and a very large cost reduction, being able to take advantage of Tosca and Vera. And then we have another customer that has also benefited from the automation of GXP testing. So they did have a set of manual tests for regression testing of their application, their Viva CRM application. It took about 32 person days of manual testing for each release. Now, they wanted to move into a continuous delivery and a more frequent release cadence, which wouldn't be cost effective with these 32 person days per release. The time to market, the cost of items, the cost of testing would be too high. So with the actual automation of all of this regression suite that they have for their GXP applications, they're able to move into continuous delivery methodology and a more frequent release cadence, and also being able to leverage these test results as part of their validation, and then just do any and then freeing up those resources to do any ad hoc or exploratory testing as well. All right, that's all I had so realize that was a lot of detail. Appreciate everyone's time, and if you have any questions, please let us know.
Yeah, thanks a lot, Nadia. Thanks a lot, HB. I think there was a lot of good information covered as far as the challenges that we want to work through, things to be aware of as we're establishing test automation frameworks, sort of best practices and processes around those items, and then how leveraging the right tools can kind of help make all that stuff a realistic possibility, and to be able to do test automation more effectively against your validated or regulated application testing landscape. So as we mentioned, we did want to leave some time at the end to go over any questions pertaining to topics that you might want to discuss that we addressed over the course of the presentation, or anything else that you wanted to address in the realm of regulated application testing, computer systems validation, test automation, any of those things. So I didn't see any questions in the chat, but is there any questions that anybody wanted to ask right now while we've got some time?
I actually received a question in a private message around the examples of audit reports and how to manage it in Vera, and if there is a possibility to have like a demo session for the tool itself. So I think that HB, this is for you better to cover. You're muted.
Thank you. Right. So in Vera itself, for our reporting, we're doing a combination of qTest reporting as well as Vera reporting. And in Vera itself, we have, for pre-execution approval and more importantly, post-execution approval, we have the actual test and the test steps all captured. And on test results, we'll also include the actual results, the tester, the time and date stamp, and any evidence that was required for test execution. We have what we call a test detail report, where we can actually generate a very traditional looking report with the test header, test steps, and embedded screenshots or links to download other attachments like PDFs or Excel files and things of that nature, so that they can actually review that item like a traditional paper document. Now, one of our initiatives for 2023 is expanding our reporting capabilities. So for these particular compliance reports that customers are asking for, we can make a more sophisticated requirements traceability matrix, for instance, which right now we're leveraging qTest. We're going to look to move that functionality into Vera. A requirement specification for a particular version of software. We ingest all those individual requirements. We will be generating a report as well. But that's a Q. Those Q1. Those are Q1 items that we're going to be working on shortly. So the data we all have. It's just a matter of putting in the appropriate tool for presentation at this point.
Yeah, and I know a question, and you mentioned CSA a couple of times. I know a question that I've heard a fair amount recently is, the ability for the adoption of a more CSA model in certain areas of life sciences organizations, enabling more easily the door to kind of be open to test automation. I was curious maybe if you had any thoughts on that or where you see that going.
Yeah, and so the easy play right now is since the guidance, since they're basically saying, oh, we haven't officially released the guidance yet, but go ahead and use it, right? Is the messaging, which some people are not comfortable with, and Kirby, can you guys add more to this? But the key for us is to be to be able to take advantage of the reduced documentation requirements, and that focus on quality is really what CSA is advocating, which will also mean less approvals necessary in the creation process and the overall process. But what we're seeing the focus on is on the really non-product validation is where we see it, right? So where it doesn't have a direct impact on patient safety is where we're seeing customers really looking to kind of take a risk, a kind of a risk-based approach on rolling that out. And so we're going to see a combination of computer systems validation remaining with the CSA being implemented, and then we'll just see how that expands over time. But the key thing for us is that review and approval process just needs to be adjusted for CSA, particularly around automation, where maybe you don't need pre-execution approval at all, which is something we can support. Maybe you just need a post-execution, and maybe it's a very limited post-execution. Now, right now, we do have customers that haven't eliminated any of that, but they have used. We do have certain current customers that are already, starting this journey. And right now, the key thing is they're limiting the amount of approvals necessary for pre and post-execution approvals. Their current take is they're like, okay, we can really slim this down to a very focused group of people and really move that review and approval process more towards, is this test automation correct? Is it following our framework? And not the same amount of documentation requirements that we saw in previous CSV initiatives.
Yes, I think it also fits into one of the challenges that I was raising earlier about legacy processes, and people who work in the industry are used to doing things in a certain way. And we have a bit of an educative and cultural component to this for the guys who are involved in the sign-offs to be accepting these new ways of working and newly found trust in automated systems and automation itself, rather than doing things in a way as it was always done, because this is how it has been done for years. So this is an element of education for us to be accepting of this way.
Yeah, I think that's a really important point to bring up, right? I mean, we've worked through that HB with a number of folks that we've worked with over the years, and it's kind of getting certain teams might be more willing to adopt new ways of doing things, new processes, new tools, and other teams might be a little bit more conservative in their approach, right? So it is also, it's education and it's getting all the teams on board and together with the vision and keeping everybody kind of in the loop and in the process with all the appropriate stakeholders across, computer systems validation and testing and software quality lifecycle to make sure that as an organization, they can move forward and adopt this stuff effectively without having their own potential internal roadblocks in addition to some of the potential stuff that they've got to navigate from the compliance side of things, right? So I think that's a very important point for people to think about as they're looking to adopt this type of methodology shift or more automation in regulated systems. So I don't know if we have any additional questions from the audience, maybe that we want to get to. No? Sounds like maybe we're good. HB or Nadia, I don't know if either of you had any closing thoughts that you maybe wanted to pose out to the room.
Yeah, I can say a couple of words. I just really believe in automation taking the lead role in the upcoming software development practices, and I think the faster we can all make a leap into trusting the automated approach and working in a more agile and flexible manner would also make it easier to address the complexity of validated system testing and regulation coverage.
Okay. Okay. Well, if there's no other questions, I know we had scheduled a little bit more time here, but I think we can maybe give everybody a little bit of time back on their calendars. So I just wanted to go ahead and say thanks everybody for taking the time to join us. If any questions do come up, we'll make sure and be following up with you after this ends, and we'll make the deck and the recording will also be available. So with that, if everybody's ready to sign off, I think we can go ahead and give everybody some time back.
Perfect. Thank you, Jason.
Thank you.
HB.
All right. Thanks, everybody.
Take care.